Okay, in this unit we're going to look at while loops, our first type of loops. So again, in traditional Java, you go statement by statement through your code, but with loops, with a while loop in particular, you can start a while loop and go through your code, and then you'll stop and loop back up and check and maybe do the code again, and maybe loop back up and do the code again. So this is the general idea: while, and then some expression that's true or false, and then your loop, and then the and bracket. So we start the loop here and we end the loop here. And so we'll go through and do these statements inside the loop till we get this bracket. When we get to this bracket, we'll check this expression. If this expression is true, we'll go back up and do the loop again. And then when we get to this bracket again, we'll check this expression. And if this expression is true, then we'll go through and do these statements again. So it often looks like an if-then, and sometimes beginning students confuse it because with an if statement we say if and then some Boolean expression in the brackets, and then sometimes we have an else. Here we have while and then a Boolean expression and some brackets. So only difference really is if versus while, and then we have the rest is similar. In a while loop you can never have an else, only if statements have else. And a while loop will keep looping. If statement is only done once, but a while loop will do it. When it gets down to this end bracket, it'll check the expression and go back up and loop again and again. Let's try to look at an example of this to kind of see it in action. So I'm going to go up, and you can download this from the attached file, this zyBooks chapter 6 examples. And this is a simple while loop, and I'm just going to open this up and go through this. So here's the main part of the program here. We print out starting the loop at the top. At the bottom here we say done with the loop. And then inside here, here's our while statement, and there's our Boolean condition, while count is less than 10. So this is a Boolean condition. It has to be either true or false. And then here's the start of the bracket and the end of the bracket. You can notice we've indented to mark which statements are inside a loop, and zyBooks also puts, this little color code here so we can see the loop coded color. So we have a couple other statements. We use a counter called count. So we say int count equals 1 here, and then we say while count is less than 10. We print out in the loop count is, and we'll print out the count each time, and then each time we'll go count equals count plus 1. So the first time we go through this, we'll say count, let's just do this once and then we'll see how it works. I'm just going to compile this and run it. And it's going to say starting loop, in loop counter is 1, in loop counter is 2, in loop counter is 3, 4, 5, 6, until it gets to in loop count is 9, and then they'll say done with loop. So let's just kind of see how it's doing that here. So again, it's at the start, it comes down and it's going line by line. It's going to say starting loop, print that out. It initializes the variable count to 1. And then it checks while 1, count, while 1 is less than 10. That's true. So it goes into the loop. And it says in loop count is, and it'll print out 1 because count is 1. And then it'll add 1 to count. Count equals count plus 1. So 1 plus 1 is 2. So now count is going to be equal to 2. And now here it checks. It glances up here and checks, is 2 less than 10? Yes, that's true. So then it'll loop back up and do this statement again. And it'll print out in loop count is 2. It'll take 2 plus 1 is 3 and save. So count will be now 3. Now here we're at the end bracket, and it's going to look up here. Is 3 less than 10? Yes, that's true. So it'll go back up here and say in loop count is 3. So it prints that out. And then it adds 1, so count will be 4. It'll print 4 out, 5. Each time it's checking, is 5 less than 10, is 6, 7, 8. So it prints out in loop count is 8. Then 8 plus 1 is 9, so count is now 9. And 9 is still less than 10. So it's going to print out in loop count is 9. And then 9 plus 1 is 10, so count is now 10. and then it checks, is 10 less than 10? No, that's false. So we're going to exit the loop. So we were stuck in here as long as this was true, but now it's false. So we're going to exit the loop and print out done with loop. And so it printed out that, and then it said done with loop. So this is just a simple loop here. What I suggest you do is play with this, try to change some code in different ways here. So let's say we started at 5, make count start at 5 and said, well, count is less than 10. What will that do to our loop? So if we run that now, I'm going to change this so it clears the screen there. Okay. So now it says starting loop, in loop count is 5, 6, 7, 8, 9, and then done with loop. So here we just started at 5, started the count at 5, and went, and each time it's checking if count is less than 10, and it'll keep doing this and adding 1 to count each time. So try different things, try that, try different numbers here. What happens if you do less than or equal to? What if you do count equals count plus 2? What are some different options you can do there? So, and see if you can then predict. You should be able to look at the loop and predict what it's going to do. So this did 5, 7, 9. Each time I'm adding count equals count plus 2 and going through and doing this. So again, you can try out a count loop, but the main idea is that the while loop, as long as this is true, we'll keep looping, doing these statements again and again. So since that's true, sometimes we have to do some initialization to start to make sure that this is true if we want to make sure we get the loop once. And also we should be doing something inside our loop to change this. Now, it doesn't always have to go forward like this. Here's an example of kind of a reverse loop. Here we set count equal to 10, and while count is greater than or equal to 1, we print out the count, and each time we say count equals count minus 1. So can you predict what this does? We start count equals 10, first time through, this will be true, and we'll print that out. So when we run this one, it starts 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and done. But again, we don't always have to do counters, but we will do a lot of different things with counters, but sometimes we'll do more input stuff. So here's a simple input statement. Here's our starting the loop, we print that out, and done with loop. And here's our loop. This time we have some answer. We're going to set int answer equal 1. And then we'll say, while answer equal 1, we'll ask the user, do you want to continue? 1 for yes, 2 for no. So if they enter 1, and we'll read that into the answer variable. If they enter 1, this will be true, and we'll loop around and do this again. So let's just try this. So it says starting loop, do you want to continue? 1 for yes, 2 for no. So if I hit 1, it'll say, do you want to continue? 1 for yes, 2 for no. I say 1, well, I can keep saying 1 forever until finally I say 2, and it's done with the loop. And actually, I don't even have to say, if I say anything but 1, it'll quit the loop. Hit 1, it'll go through the loop, but I hit any number and it'll be done with the loop, because it'll just keep looping as long as answer is 1. So again, in this time, as long as this is true, we'll keep looping. Now we could be doing other stuff in this loop and then asking, do you want to continue, and read that in. But here we're just repeating, do you want to continue, again and again. Now you could also change this so that this was a string. So let's say you wanted to make answer a string. String answer equals 1. We're going to make, rather than 1, we'll say yes. And we'll get back to this in a sec and say, do you want to enter yes or no? So we want them to enter yes or no. And so we'll read in, rather than doing a next int, we'll read in a string. So we'll do next. So except for this, we'll ignore that for now. We're going to say string answer equals yes. And basically we want to say, well, answer equals yes, but that's not going to work, as we'll remember in just a sec. So that's what we want to say. While answer equals yes, we'll say, do you want to continue yes or no? They enter yes. We read that into the answer variable. If it's yes, they'll continue. But this is not going to work. If we try to compile this and run this, it compiles fine, but if we type in yes, it just ends the loop. If we type no, it still ends the loop. Whatever we type, it'll end the loop. And the problem is, if you remember with strings, we can't use the equal equal with strings. We used to have to say if answer dot equals. There's also a dot equals ignore case if you remember, but we'd have to say, but for now I'll just keep answer dot equals. Have to make sure I do the right capitalization then, since I'm just using dot equals. So answer dot equals yes. So now if I run this, it should work. Do you want to continue if I type in yes, 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 but if I type in no, it'll quit. In fact, if I type in anything other than yes, that exact capitalization, if I just say lowercase yes, it'll still quit because I'm using just dot equals, not dot equals ignore case. So again, this is just another way of doing a loop. It'll just keep looping up and doing this statement as long as this is true. And again, inside the loop, we're doing something to change this Boolean expression, so at some point it'll be false. We're also doing some initialization at the start to make sure that this is true the first time, assuming we want to make sure we go through the loop at least once. In this case we do, because we asked them something inside the loop. Okay, so let's come back into zyBooks for a little bit. So again, it walks through here, talks about loop bodies and that sort of stuff. Go through these exercises. And again, you should be able to go through these different loops and see what's happening, see how many times this loop is going. So these are good practices to see if you can understand what loops are. They again ask a similar question like we did. Here they're going to enter, they're going to print out a face with the character. So it prints out like a face with an A, kind of looks like a face, or with X's, kind of looks like a face there. But until you enter Q, and they're going to be reading a character each time. And again, remember when they're reading a character, it's this weird thing where they have to read in a string, and then they have to grab the first character from that string. So they're doing it this way rather than in my loop. I just read in the whole word, yes or no, and did dot equals for that. So, okay. Again, go through these. These are more while loops. Here you have to write the Boolean expression inside the while loop. So this is good exercise to get used to writing Boolean things. And again, it's good to practice loops. The more you practice loops, the more you'll get used to how they work and what they run with. So let's look at this example of ancestor printer. Now, we can't run this one here. Let me move this over. They just give this example one. So I've actually moved this over into Bluej so we can see it in the Bluej. So if you want to run the ancestor printer, it's here. Same exact code as the other one. It says enter a year in the past, negative for BC, and then it reads in the user year. The current year is set to 250 and the number of ancestors is 2. And what this does is say, says that, well, right now you might have 2 parents or 2 ancestors here, but if you were to go back in time and ask how many grandparents you had, and they're saying, let's say 20 years ago, when for each generation, so go back 20 years and there would be 4 ancestors, and then go back another 20 years and it'd be 8. It would double. So you have 8 great-grandparents and 16 great-great-grandparents, and so it kind of goes back, does a genealogy kind of check of how many ancestors you would have at different areas. So this is our loop while the current year is greater than or equal to user year, and they ask you to enter a year in the past and read that in. So this is our Boolean statement. We print out the ancestors, and then each time we take the number of ancestors and multiply it by 2. So we'll start with 2 and 4, 8, 16. We'll double, well, not double, yeah, we'll multiply it by 2 each time. And then we also take the current year and subtract the number of generations. So we can run this And you can go back to like the 1920s. And so this is your parents, parents, grandparents, great grandparents, great great grandparents, and great 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 grandparents here. You can also run this further back if you want. Now, one thing you have to watch is that, I mean, it works fine. Oops, that's not what I wanted to do. I wanted to do this main. Works back fine as you go back further. But these numbers will start getting bigger. Let's say you're going back to the Mayflower era. That sort of, oops, I'm not doing that. Okay, let's try this again. Let's say we're going back to the 1600s. So now again, we're getting bigger and bigger back then. So you have to watch because we're just storing these in integers, and if you remember, integers were actually wrapped. So you can actually go back to, let's say we're going back to the time of the Egyptians, 3000 BC. They're going to actually have negative numbers here because we will roll over integers. So you can't go back very far. At some point, the integers get so big they start getting negative. So, and we don't check for that at all. But it's a fun little program to write and good illustration of a loop. So you can try that out here. Talks about some common errors, and that's an infinite loop. So if you're looping around and things get stuck, you can run into problems. Let's show you how to break an infinite loop in Bluej, because that's it. So notice right now this little run symbol is gray, meaning we're not running a program. Now while we're running a program, this will be red. I'm going to open up this simple loop, and we're going to, let's say we start at 1, and while count is less than or equal to 10, and add 1 to count each time. So if we compile that, if you watch this, it should run through and change this to red real quickly. Did you see it blink red real quickly as we ran through? Here, maybe we'll run it through a little bit longer. So now, see the red? Did you see that run? Okay, it was red a little longer until it counted to 10,000. But let's say we wanted to run this forever. So rather than saying like count is less than 10, let's say we accidentally said, oops, while count is greater than 1, 10, or yeah, greater than or equal to 1. So it's going to enter the loop once because count will be 1, so it'll be greater than or equal to, let me get my spacing right, 1. But it'll keep adding, so it'll keep doing this forever as it adds to count. Actually, it might end eventually because these integers might run out. But let's run this for a while and see. So now we're cutting this infinite loop. We're just going to be looping forever. And we see this work indicator stuff. So if you get into some infinite loop where it's looping forever, you can right click on this and say reset the Java machine. That'll stop the printout and get you to run back. So you right click on this red, I call it the candy cane bar, but it's a status bar. And then you can reset the machine. Okay, so that talks about this common error. Let me fix that now. While count is less than 10, that's what we want. Then eventually it'll be false. Okay. So they have more loops for you to try out here and activities. Again, they're going through this loop where similar to the ancestor print one. So just go through these participation activities. And then there's a nice little challenge exercise here to see non-negative looper to keep looping here. So see if you can go through these. These are all good activities. Remember, the challenge activities are not required, but they're good practice. It gets you good preparation, so you can do the challenge activities if you want, and like I say, they're good practice. So that wraps up the while loop. We'll spend a couple more units on the while loop and then look at the for loop in the future.